All right, our next example here says, what is the value of z so that vector u and vector v are collinear? So to be collinear, they have to be scalar multiples of each other. So let's look at vector u here. Whoops, grab the proper tool. Vector u is 1, -5, and 8. So there's my vector u. And my vector v is equal to -3, 15, and then something which we don't know yet. But you probably can figure this out pretty quick. So to go from 1 to -3, I'd be multiplying by -3. And to go from -5 to 15, I'd have to multiply by -3. So that means to go from 8 to z, to make it collinear, it's going to have to also get multiplied by -3. So we can make a nice little equation out of that if we want. We're going to have 8 times -3 would equal z. So our z is going to equal -24 to be collinear. All right, now we have an example of PQRS, and it's a parallelogram with 3 of those points being defined for you, and you have to determine what are the coordinates for point S. So I'm going to sketch this out and just remind you of some things that you should know about how to label quadrilaterals or any polygon where we have multiple letters like this. So we've got a point at -1, 2, so P could be roughly here at -1, 2, and Q is at 4, -3. So I'm just roughing this out here. If you have actual grid, you can do it on grid, but you don't need to. And then R is at 3 and -6. So R is here at 3 and -6. So when you have the name of our parallelogram in this case, what this implies, the order matters here. It implies that P attaches to Q. So I could join P to Q, and then Q joins up with R. Q to R would be here, and then R joins up with S. So it is a parallelogram. I'm going to estimate where I think S will be. So to be parallel, I think S is going to be somewhere here, and I'm just going to label that with XY because I don't know point S yet. So R joins up with S, and then S joins back with P. So this is the convention. This is the way we always figure out how to join our points or our vertices of our polygon. It doesn't have to just be a parallelogram here. All right, so for this to be a parallelogram, we know that sides have to be parallel to each other, which means they have to run in the same direction. So, and in fact, the vector itself has to have the same length as well, which then means I could talk about vector PS. Vector PS would have to be equivalent to vector QR. So we knew that back when we did our geometric vectors. So that's the case. But now we're working with coordinate vectors here. So PS would be PO plus OS, and then QR would be the sum of QO plus OR. And then what we have by these, we can come up with our vectors, except I don't have PO. What I have is OP, so I'm going to make that negative OP to correspond to positive PO. And we're adding OS. And then we have QO, which again would be negative OQ. And we're adding OR. All right, so let's put some things into play here. I'm going to just turn these around. I'm going to put my OS first and then subtract my OP, just to make it a little bit more pleasing to the eye. And then we're going to actually put in our things here. OS, I don't know its coordinates yet, so I'm just going to use the XY. OP would be -1, 2. OR is the vector 3, -6. And OQ is the vector for -3. And then I'm going to use our rule that we have earlier. X take away -1 would be X plus 1. So I'm combining the components here. Y take away 2 will just be Y take away 2. And that has to equal 3 take away 4, which is -1. And then -6 take away -3 would be -3. So for these two vectors to equal each other, their components have to equal each other, meaning x plus 1 would have to equal -1, and y minus 2 has to equal -3. So that means x plus 1 is equal to -1. Subtract 1 from both sides, x equals -2. And we also have y minus 2 equaling -3. Add 2 to both sides, we get y equals -1. So therefore, S is at -2, -1. So hopefully that makes sense. If you have any questions, please feel free to send me an email and let me know.